In this video, we are going to discuss about the continuity and the differentiability. So before we start the video, I would like to ask, if you haven't subscribed my channel, kindly subscribe the channel so that you can get the useful videos as I upload them on time about the different topics on the algebra and calculus. Now, as we know that we are studying the continuity and differentiability, let's discuss first of all that when the function are discontinuous and what kind of different discontinuities we already have discussed so far in previous videos. You all know, you all know that there are two important kinds of discontinuities we already have discussed. That is the removable discontinuity or the non-removable discontinuity. Now, removable discontinuity means whenever there is a function and inside and in between the function there is a hole, then that kind of discontinuity is said to be removable discontinuity. Now, we also have studied about non-removable discontinuity. So the first kind of non-removable discontinuity is also the jump discontinuity. It is also said to be non-removable discontinuity, but it is also known as the jump discontinuity. And you can see that in jump discontinuity, at point A, the two lines are not meeting each other, which means that the limit from the left hand side is not equals to the limit of the right hand side. That's why the limit does not exist and hence the function is not continuous. The next kind of the discontinuity is said to be the discontinuity found due to the vertical asymptote. It is also said to be non-removable discontinuity or infinite discontinuity, or the discontinuity due to unbounded behavior or due to vertical asymptote. So this is also said to be the non-removable discontinuity. So as we are, our topic is related with the continuity and differentiability in a closed interval. So understand that a function is differentiable when the function will be continuous. So the condition of differentiability is to be continuous everywhere in the closed interval. Differentiable. So differentiability depends on the continuity of a function. So it means that any function which is continuous can be differentiable. But if a function is differentiable, then 100% you can say that it is continuous. So it means you can say in short that differentiability depends on the continuity. So if a function has any kind of the mentioned discontinuities, it means it is not continuous and hence it is not differentiable. Now the second thing comes that when the function is not differentiable. So understand a function could be differentiable when it will have the smooth curve in the given interval. So for example, if I want to understand about the differentiability of a function in a closed interval a till b, then you can see from a till b there is a smooth curve. So everywhere you will see that the curve is so smooth. It means you can find out the tangent at each and every point in the given interval, and hence the function is differentiable. So the condition of differentiability is to be continuous and have the smooth curve. Now let's see the graph of an absolute value function. So for example, the absolute value function, that is absolute modulus x. So you can see that the given function is continuous everywhere. The function is continuous everywhere. But having the sharp turn, this sharp turn at x equals to 0 shows that the function is not differentiable. So why it is not differentiable? Because it doesn't contain the smooth curve. At 0, it has a sharp turn, or it has a sharp curve, or it has a node in the graph. So due to this node, or due to this sharp turn, or due to the sharp curve, we will say that this function, although it is continuous but not differentiable. Now, in order to understand, you can see that the slope is decreasing, right? The slope is negative. And then on the right hand side, the slope is positive. But at 0, you cannot determine the slope. So that's why this is not differentiable. Now, if you want to understand this very well, you can say that let's suppose the x, so when x is less than less than 1, okay, and it could be negative x when x is greater than 1. Now, if I want to take the derivative of x, I know that it is equals to 1, and when I want to take the derivative of negative x, it is equals to negative 1. It means the derivatives are not equal from the left and the right hand side, and hence the function is not differentiable. Now, if we have any kind of the function, let's suppose it is x to the power 1 over 3. So if we try to graph this function x to the power 1 over 3, you will see that the graph looks like this. So what is happening at 0? At 0, you will see that the tangent line, if you want to draw the tangent here, so you will see that the slope is undefined. We know that whenever we have a horizontal line, for a horizontal line, slope is 0. And for a straight line, so the slope is a straight line, a straight vertical line, so you can say that the slope is undefined. So in such cases, when we have the undefined slope at any point, then we can say that the function is not differentiable. Although the function is continuous everywhere, but the function is not differentiable at x equals to 0 because of this straight tangent line whose slope is undefined. Now what will happen if I have a function x to the power 2 over 3? So actually x to the power 2 over 3 can be written as x square whole to the power 1 over 3. So we can, if we graph this function, you will see that this graph will be like this. It is a kind of the graph which has a cusp. So let me draw this graph again for you. That is, it is like this. So this means that it has a cusp. So although there is a graph, but you can see that the graph, yani if you look at the steepness of the graph, you can see I didn't draw it very nicely, but you will see that if you will try to draw the tangent line over here, again you will get an undefined slope. Which shows that the function is not differentiable. Now coming to the algebraic side. Coming to the algebraic side, and in order to understand that which kind of the functions are differentiable and which kind of the functions are not differentiable, understand that the functions are differentiable if they are continuous, yani the function is continuous and its derivative is also continuous. So for example, I have a function x square minus 2x plus 1. If I take the derivative is this function. Now first of all, find out what is the domain of this function. This is the polynomial function, so you can say that the domain is all real numbers. Now if we take the derivative of this function, we will get 2x minus 2, so the domain of this derivative is also all real numbers. So if the domain of the function and the domain of the derivative is also continuous, so you can say that the function is differentiable. Now, if we see the graph, the function equals to absolute value of x. Now, when we have any function with the absolute value of x, we can say that it has a function. Yani if we open it, so from the left hand side the function is equals to x, and from the right hand side the function is equals to x, and from the left hand side is negative x. So the derivative of the function from the left hand side is negative 1, and the derivative of the function from the right hand side is positive 1. Now since they are not equal to each other, so we can say that the function is not differentiable. One more example. What if the function has x to the power 1 over 3? If we take the derivative of this function, we will see that 1 over 3 x to the power negative 2 by 3. Now bring the power down in the denominator to make the function, to make the exponent positive. Now the domain of the function itself is all real number. But if we write the domain of the derivative, you will see that it becomes a kind of a rational function, which means that x to the power 2 by 3 should not be equals to 0, and hence x should not be equals to 0, which means the domain is all real numbers except 0, which means that the function is not continuous at 0, and hence the function is not differentiable. So in short, the functions who have the sharp turns at any point, or who has the cusp at any point, so that at certain point the tangent line slope becomes undefined, so it means that they are not differentiable at that particular point.